on land, sea, or aircraft in flight, nuclear or conventional, rockets and missiles make up some of the most awesome weapons in the arsenal of the United States today. Many of these weapons, capable of tremendous range and precision accuracy, bring with them state-of-the-art weapons technology and incredible firepower as they deliver their payloads on the enemy.
TOW, the versatile, mobile, heavy assault anti-armor infantry weapon system, designed, developed, and built by Hughes Aircraft for the United States Army and Marine Corps. Combat tested, TOW has proved to be highly accurate and devastatingly effective. In addition to its use on a tripod, TOW was designed to be mounted on many different platforms, thus increasing mobility. These platforms include the Jeep, the Humvee, and many other wheeled and tracked vehicles. The combat record of TOW has been impressive. In this combat footage, taken through the gunner's sight, the effectiveness of the airborne system is illustrated. TOW is simple to operate. After the missile is loaded, the operator acquires the target, launches the missile, and keeps his sight trained on the target. An infrared sensor in the sight sees the infrared source on the missile and supplies the position of the missile to the guidance set. The guidance set processes the data and generates the steering commands, which are sent to the missile over the trailing wires. The operator needs only to keep his crosshairs centered on the target until impact. As the armor threats become more difficult to defeat, the U.S. Army will continue to improve the effectiveness of the TOW weapon system. Under development for the TOW-2 missile is a new large-scale integrated electronics unit, including a new microprocessor central processing unit. Coupled with a modified night sight and state-of-the-art digital electronics retrofitted into the launcher, the TOW system now has the capability to operate day and night through battlefield smoke and obscurance. Improved algorithms included in the digital electronics of the guidance set would increase the performance of TOW missiles, particularly in probability of hit and kill at all ranges, and reliability and survivability in countermeasure environments. The TOW weapon system, reliable and easy to maintain, continues to evolve in performance, to increase in effectiveness, and to provide higher lethality against the armor threat of today and into the next century.
Rockwell International's Hellfire is the United States Army's newest and most effective operational anti-armor weapon system. Hellfire is laser-guided. There are no wires controlling the missile. This allows the helicopter to launch the missile and leave immediately to avoid enemy fire. A ground laser designator team in a hidden location places a laser spot on the target's most vulnerable area. The spot is invisible, but this special camera allows it to be seen for this demonstration. The Hellfire missile locks onto the laser spot and follows it to impact. The laser spot can come from the launch helicopter, another helicopter, or from another aircraft. Since the helicopter is not tied to the missile by wire, and the missile flies at supersonic speed, exposure time is greatly reduced, which means greater safety for the helicopter and crew. Hellfire can also be launched at night and in adverse weather for better concealment from the enemy. Hellfire can be operated in the direct fire mode, where there is line of sight to the target, and the missile is locked onto the target before launch. Or the helicopter can take advantage of concealment and launch in the indirect fire mode. The missile acquires the laser spot after launch and locks onto it while in flight. With Hellfire's accuracy and shape-charge anti-armor warhead, Hellfire defeats all known armor. Sequential or salvo-type launches are possible with Hellfire in combination with one or more designators. These engagement modes are extremely effective for target-rich environments. Hellfire has been launched from the ground. Being able to fire the missile in the indirect mode allows the launch crew to take advantage of natural terrain masking for protection. The GBU-15 system, developed by Rockwell International, gives the United States Air Force a standoff strike capability against a variety of defended targets. GBU-15 increases the aircraft's chances of survival by allowing it to operate outside enemy defenses that protect high-value targets. The weapon is launched from standoff range, and the aircraft can immediately leave the launch area. The weapon has a television seeker in the nose. The picture from the seeker is transmitted by RF data link to the cockpit of the launch aircraft. The weapon system operator uses the television picture to locate the target area. When the operator identifies the target, he can lock on the weapon's automatic tracker. As the weapon reaches the top of its climb and begins a descent to the target area, the operator can improve the aim point if he desires and continue on automatic track. He also has the option to manually guide the weapon to impact. The GBU-15 was designed to be effective against such targets as bridges, airfields, industrial sites, caves or aircraft shelters, air defense sites, and ships. GBU-15 is modular in design for low-cost operation. A Mark 84 2,000-pound bomb from Air Force inventory is used for the base. The seeker, warhead adapter, and control module are fitted to the bomb. Wings are added to complete the weapon.
The Tomahawk family of cruise missiles, developed to provide a versatile weapon for America's defense. Tomahawk's features: it is small, low-flying, far-ranging, evasive, reliable, and accurate. The Navy's sea-launched cruise missile, Slickum, was the first member of the Tomahawk family and continues in full-scale production. After launch from the torpedo tube of a submarine, just one of 4 launch platforms, the missile broaches, powered by an expendable rocket motor. Control fins deploy for stability. In seconds, the engine inlet and wings deploy. The spent rocket motor is jettisoned. An efficient turbofan engine takes over, and Tomahawk speeds toward its programmed target. If the assigned target should be an enemy ship, Slickum systematically searches a large area of the sea, locking onto the signature of the target ship, and with precision accuracy, homing in for the kill. Fitted with a conventional or nuclear warhead, Slickum can be assigned a target up to 2,500 kilometers inland. Navigation is inertial, refined with updates from the Terrain Contour Matching System, TERCOM, and has an on-target accuracy within meters. A submunition dispensing variant of Tomahawk is designed to fly against revetted aircraft and similar targets. In this variant, packs of submunitions are ejected from the Universal Payload Bay. The Universal Payload Bay can also be used for other types of submunitions or countermeasures. With submunitions gone, Tomahawk then flies on to attack a final target as an accurate kinetic force projectile. Slickum is readily launched from surface ships. This armored box launcher is on the battleship New Jersey. CGN-9, 36, and 38 class cruisers, plus DD-963 class destroyers like the USS MIRACL, are also receiving Tomahawk capability. Another launch configuration is vertical. Here, the missile is stored below decks in an upright position and launched straight up. On CG-47 class cruisers, DD-963 class destroyers, and DDG-51 class guided missile destroyers, each ship is able to carry a larger number of missiles in a limited space, increasing firepower. In submarines, 12 tubes located in the bow of SSN-688 class boats provide the vertical launch capability, in addition to launch from the torpedo tube. Submarines provide Slickum with ideal launch platforms, virtually free from interdiction and adding a new dimension to fast attack boats.
Maverick is a precision-guided air-to-surface missile in the 500-pound class. The Maverick missile family consists of several types of missiles used for different applications. Some of the more unique Maverick missiles include the AGM-65A, which is a TV-guided model with a 5-degree field of view camera in the seeker, a centroid tracker, and a single-stage solid propellant boost-sustained rocket motor. The AGM-65A's 125-pound shaped charge warhead is designed to defeat heavy armor and reinforced concrete. Operational use of this missile is in the fire-and-forget mode. The pilot can slew the seeker for rapid lock-on to the target using a TV visual display, launch the missile, and immediately take evasive action. The Maverick AGM-65B uses television scene magnification with a 2 to 5 degree field of view camera and improved video symbols on the cockpit display. Maverick AGM-65D has an imaging infrared seeker which tracks the natural thermal image of a tactical target and surrounding environment, providing a pictorial display of the target in darkness, haze, and smoke. The AGM-65E is fitted with a laser seeker, which homes in on a target illuminated by a ground or airborne laser designator and a new 298-pound penetrator blast fragmentation warhead, developed to extend Maverick's capability against larger or heavily fortified targets. It can be used by day or night, as the pilot of the launch aircraft does not need to acquire the target visually. Anti-aircraft missiles are fired upon enemy bombers and fighters and are also used to knock out incoming rockets. These weapons are launched from other aircraft, armored ground vehicles, surface ships, and infantry forces.
The best known of the fleet air defense weapons is Standard Missile, which evolved from Terrier and Tartar missiles and has continued to adapt to the ever-increasing threat to the free world's navies. Standard Missile is manufactured in two distinct surface-to-air configurations. The medium range uses a dual-thrust rocket motor, and the extended range has a separable booster. There are two versions of Standard Missile. Standard Missile 1 has been in production since 1968, and Standard Missile 2 since 1976. Both these missiles have been continually upgraded by incorporating evolutionary technology to increase accuracy, reliability, and firepower to meet the changing threats. Today, Standard Missile 1 uses the same modern monopulse receiver as the newest version, Standard Missile 2. Standard Missile 2 uses this monopulse receiver in conjunction with inertial reference and command links. Such features have significantly reduced reaction time while increasing firepower and area coverage. The latest version of Standard Missile 2 has been improved by adding new propulsion units to both the medium range and the extended range configurations. The new Mark 70 booster for the extended range uses the same metal parts as the proven SM-1 Mark 12 booster, but has a new propellant grade. The new Mark 104 dual thrust rocket motor incorporates the latest in propulsion technology and increases missile velocity considerably.
AWC, Captain. My take is that there are currently 5 targets.
A digital signal processor permits engagement of tomorrow's higher speed and reduced radar cross-section targets. The threat continues to improve.
You've got 5 airborne right now, and the 5th.
The combination of Standard Missile, its planned evolution, and the Aegis combat system will provide the United States with defense against both high-altitude and low-altitude anti-ship threats through the 1990s. Standard Missile is deployed not only on U.S. ships, but also on ships of 7 allied countries. The AIM-7M all-weather missile system was developed for the Navy and Air Force air superiority fighters to defend against enemy aircraft. General Dynamics is second source manufacturer of Sparrow. The monopulse receiver of the AIM-7M offers improved performance against maneuvering targets in the presence of countermeasures. The surface-to-air version, RIM-7M, also known as Sea Sparrow, is used in a self-defense role with the U.S. Navy and its allies. RAM, the rolling airframe missile, is the basis for a new generation quick-reaction self-defense system designed to effectively counter the anti-missile threat. By applying the rolling airframe principle, guidance, signal processing, and control channel requirements are substantially reduced. This results in fewer components, lighter weight, smaller size, increased reliability, and lower cost of this 5-inch diameter missile. The use of passive radio frequency and infrared guidance provides for autonomous in-flight operation, allowing simultaneous target engagements and the high rate of fire necessary to assure ship survivability during saturation attacks. When the missile is launched in the direction of the target, it maintains that direction until the passive RF guidance signals call for a course correction. RF guidance signals also point the IR seeker toward the target until there is sufficient IR signal to acquire the target in terminal homing.
The current version of the Phoenix missile, AIM-54A, is tactically deployed around the world on the Navy's F-14 Tomcat. Phoenix is the Navy's primary long-range air defense weapon and one of the world's most technologically advanced tactical missiles. It provides air-to-air attack capability well beyond that provided by any other air-launched missile in existence. Its unique performance features have been clearly demonstrated in over 150 flight tests and Navy operational launches. As flight tests of the improved Phoenix continue, there is every assurance, based on successful launches to date, that the reborn Phoenix missile, the AIM-54C, will be ready to meet the higher intensity aerial threats through the next 2 decades.
Air defense is a key element in any land battle. The Stinger man-portable weapon system provides the foot soldier with a flexible and effective counter to hostile air attack. Weighing less than 35 pounds, this weapon provides the velocity and range to intercept high-speed, incoming, crossing, and outgoing planes and helicopters at greater distances than ever before. This Stinger forward area low-altitude air defense system now gives the U.S. Army, the Air Force, and the Marine Corps a superior air defense shield against helicopters and high-speed jets. Over 300 guided flights have demonstrated Stinger's superior performance against a variety of targets and has verified the accuracy, lethality, and reliability of the Stinger weapon. Annual reliability flight tests and fly-before-buy contractual test results have been outstanding, thus assuring the users of high-quality, highly reliable weapons. POST, an acronym for Passive Optical Seeker Technique, is a highly advanced guidance system which requires only a modular change to the existing Stinger weapon. The combination of rosette scanning and microprocessor control significantly enhances target detection and countermeasures capability. The 2-color infrared and ultraviolet rosette scan seeker provides an option to track targets in either band. POST has increased immunity to countermeasures, better background discrimination, and improved signal processing electronics. Stinger POST enhances the high operational effectiveness and terminal lethality of the Stinger weapon system while retaining the advantage of the fire and forget operation. This remarkable weapon system is easily adaptable on a variety of platforms. Stinger can provide an air defense capability for numerous military vehicles, vessels, and aircraft. Ships, helicopters, and land-based vehicles are all adaptable for Stinger weapon mounts.
Chaparral is the Army's short-range surface-to-air missile system. The Chaparral missile is a heat seeker. Once launched, it will chase down the hot tailpipe of planes, choppers, or other missiles and deliver its warhead with devastating accuracy. Equipped with FLIR technology, the Chaparral is capable of fighting day or night and in fog or smoke. Effective against all types of aircraft at low altitudes, the Chaparral is mounted on a tracked vehicle or can be towed by a truck or jeep.
When the concept of a submarine-launched missile was first proposed in 1955, skeptics said it could never work. But the successful launch of a Polaris test missile from the submarine USS George Washington on 20 July 1960 ushered in the era of the fleet ballistic missile, and the Navy's submarine-based weapon system has stood the test of time. The Navy's first fleet ballistic missile, the Polaris A-1, had a range of 1,200 nautical miles. The Polaris program extended the missile's reach, achieving a range of 2,500 nautical miles with the A-3 missile. Then the Poseidon, or C-3 missile, introduced multiple warheads, each capable of reaching a separate target, significantly enhancing the system's effectiveness. And the Trident development program resulted in a more survivable deterrent, an improved missile with a range of 4,000 nautical miles, and a new submarine, faster, quieter, and most of all, larger, carrying 24 missiles instead of 16. The Trident II, or D-5 missiles, carried on board the Tennessee-class submarines, the newest and most powerful in the Navy's underwater arsenal, incorporate major advances in missile design and manufacturing. For example, graphite epoxy, an extremely strong yet lightweight material, is used for the casings of the solid propellant rocket motors. This, along with other advancements, allows the Trident II missile to achieve a range greater than the 4,000 nautical mile reach of the Trident I.
Today's nuclear missiles have been developed to face the unique challenges presented by a world military arena. The Boeing air-launched cruise missile is a small, extremely versatile, unmanned, self-guided airplane that is capable of electronically reading the terrain over which it flies. It compares these readings with maps stored in its onboard computer, guiding itself through the enemy's defense system to predetermined targets. Operational missiles are armed with W-80 nuclear warheads and fly at subsonic speeds. The ALCM range of more than 1,500 miles and low radar cross-section give the Air Force a weapon that can be launched over non-hostile territory and still reach major targets. It is carried by the B-52 bomber and is compatible with the B-1B long-range combat aircraft. One B-52 bomber is capable of carrying 20 ACLMs. The Peacekeeper is a 4-stage intercontinental ballistic missile produced by Boeing Aerospace and Electronics. Peacekeeper is designed to deliver 10 re-entry vehicles to independent targets at a nominal range of 5,000 miles. Formerly known as the MX missile, Peacekeeper is a vital addition to the Minuteman ICBM system and was originally developed to offset the continuous buildup of Soviet strategic weapons capability. 3 of Peacekeeper's 4 stages use solid propellant materials. Hydraulically operated thrust vector actuators move nozzles to guide the missile along its flight path. In the 4th stage, the post-boost vehicle uses a liquid bipropellant rocket propulsion system that provides velocity and altitude correction for the final phase of flight. The post-boost vehicle maneuvers each time a re-entry vehicle is released. The re-entry vehicles contain the missile's nuclear warheads. They are conically shaped and covered with ablative material to protect the weapons during re-entry into the atmosphere. Each re-entry vehicle is deployed at a position that will allow it to follow a ballistic path to its target. Rocket technology has taken us into space. In 1969, we put a man on the moon. That event, along with our increasing knowledge, has made space a very possible battleground in the coming decades. The news has been filled with stories and controversy over SDI, the Strategic Defense Initiative. The Soviet Union is believed to have a ground-based laser already capable of destroying satellites in space, and, like the United States, has for many years had the ability to take out satellites with missile technology. Many directed high-energy weapons are being developed for future use. One such weapon, the Skylight Mid-Infrared Advanced Chemical Laser, or MIRACL, couples a beam director with an advanced high-energy chemical laser. In this experiment, a rocket engine mixes various chemicals, exciting their molecules to a higher energy state. When these molecules drop back to a normal state, they transmit photons into an ultra-concentrated beam of light energy. Out in the desert, an experimental Skylight system has been tested successfully, receiving a target designation from a radar beam, then directing its beam straight at the target. The beam tracks the target, thermally burning through at the precise point of aim, slicing through and destroying it. Besides ground-to-air defense, programs like Skylight have the adaptability for other applications, such as anti-missile defense aboard ship. The United States Strategic Defense Initiative is capitalizing on many forms of directed energy. Although most of SDI must be carried out in secrecy, recently released footage is giving us a closer look at these Star Wars projects. In the Delta 181 experiment, payloads of sensors and other test objects are sent aloft, taking position in the Earth's orbit. Delta 181, with a payload of 14 sensors, helped characterize surface test missiles against a variety of space and Earth backgrounds. These ultra-sensitive devices are able to detect differences in groups of in-mission enemy ordnance. Lighter objects are identified as decoys by slight differences in motion. Reporting back to central supercomputers, the data enables the system to act on real warheads and ignore the decoys. Delta 183, the next experiment in the Delta Star series, continues this line of research with a projected 9-month orbital life. After taking position, Delta Star, with an even higher order of sensors, begins collecting data which will characterize the plumes of several sounding test rockets launched at intervals. Studies in kinetic and directed energy have broadened the range of knowledge and generated quantum leaps in advanced military technology. By combining laboratory development and large integrated ground and space experiments, numerous SDI interceptor advances have been made in relatively little time. In the Bear experiment, neutron particle beam tests exploit the capability of a stream of atomic particles to penetrate deep into targets. During a short space flight, the vehicle carrying the beam accelerator rotates in position while the neutral particle beam is propagated. In this first ever firing of a neutral particle beam in space, no targets were used. Rather, the behavior of the beam during firing was studied to determine the effects of space and lack of an atmosphere. This rotation of the entire satellite fixes aim on the target. Unlike the laser beam, which cuts through its targets, the neutral particle beam penetrates deep inside of ICBMs and other hostile intruders, destroying or disrupting their workings from within. 10, 9, 8, 7. The hover test experiments show that it is feasible for vector thrusters to fire for microseconds to keep an interceptor on target. This technology was first achieved on the ground at Edwards Air Force Base. Hover tests at Edwards involved this 21-second flight of an SPI projectile facsimile in a laboratory. The deployment concept for strategic defense would send a number of orbiting interceptors on missions of non-nuclear destruction. Attacking missiles are killed in early phases of flight by the kinetic force of impact at extremely high speed. Ground-based operation of defenses deep inside the atmosphere is being developed by projects such as the Army's Flexible, Lightweight, Agile Guided Experiment, or FLAG. It's a concept of using advanced technology to hit a bullet with a bullet. A U.S. Army Lance missile is fired toward the test area from about 32 miles away. 100 seconds after this target is launched, they raise the 12-foot-long flag in hot pursuit. The improved millimeter wave built-in radar locks onto the Lance. Flag's onboard computer then chooses from 216 rocket motors about the size of shotgun shells, firing the motors appropriate to moving the flag vehicle on the correct course at the corresponding command. This combination of onboard microprocessing and advanced radar gives SDI the guidance necessary for non-nuclear intercept of targets down to Earth and close to home. The rockets and missiles you have seen in this program represent some of the hottest weaponry in the United States arsenal. These weapons are currently deployed in hotspots throughout the world and will decisively determine the outcome of today's warfare.